It has become increasingly hard to make a judgment about how real our world is. Our experiences are in a lot of ways simulated, virtual, planned and increasingly abstract. We are far away from the time that buying something meant actually exchanging goods. We do not exchange our cows for sheep anymore. We hardly even use paper money to exchange goods. We are mostly exchanging invisible numbers using plastic cards. We can have meetings with people all over the world without actually meeting them in the flesh. When you're calling someone, you're simulating being there with the other person. We're connecting through interfaces. Sometimes we don't even know what things are or do anymore. We see the world through screens. We are constantly in an area in between reality and simulation. A lot of the things we see on our screens are now part of our reality. We conceive them as real. Humans are becoming more machine-like, and machines are becoming more human. This isn't necessarily scary. But these changes are continually challenging us as human beings. We need to readjust and find our comfortable center in the world. There are even digital detox camps for people that believe the digital world is having a bad impact on them. You are required to have good judgment of your use of technology, which, admittedly, isn't always easy. But people romanticizing a world without technology are simply denying the technological nature of humans. People longing for simpler times might forget that technology is there to make our lives simpler, not more complex. Until the 1960s, parts of Africa still used cows as a currency. But it became quite apparent that this system wasn't scalable. The use of cows as a currency resulted in an overpopulation of cattle, overgrazing the fields. The environmental problems this caused went on till the 1980s. The idea of a simpler world might seem romantic to some, but it is mostly not very realistic. Technology has helped us make life easier and more understandable. New technologies can sometimes be hard to accept. To help people grasp new technology, we make use of already established visual language. Windows, wallpapers, the trash can, the floppy drive, the shopping cart. New inventions always mirror old inventions. Cars were designed as horseless carriages. The QWERTY keyboard is based on the typewriter. Mirroring old inventions doesn't always make sense. The QWERTY layout was designed for typewriters not to get the keys trapped. By placing the most used keys as far from each other as possible. In the age of computer keyboards and touchscreens, this problem has ceased to exist. Sometimes parts of technology can become dominant standards. Even though they don't always make a lot of sense anymore, and there might be other and better ways. We still use them, because we are used to them. Making it harder to see things in a different way. MIDI, the now dominant standard for digitally transcribing music. This method of longer and shorter blocks representing music has formed the way we look at making music on digital devices. While there might have been better and more interesting ways of representing music, this has now become the industry standard. Things really start to become confusing when digital representations of real-life things start popping up in the real world. Blurring the separation between the real and virtual even more.
I started noticing things like this in the world. This is a cushion on sale in a furniture store that's pixelated. This is a strange thing. This is a look, a style, a pattern that didn't previously exist in the real world. It's something that's come out of digital. It's come out of a digital way of seeing that represents things in this form. The real world doesn't, or at least didn't, have a grain that looks like this. But you start to kind of see it everywhere when you start looking for it. Shoe designers are good for this stuff. This is the low-res shoe by United Nude. This is, again, a making real of a digital artifact, something seen at low resolution and kind of carried on out into the world as an aesthetic. This is doing a very similar thing. It's fine to like things in the virtual world. It's a simple interaction that becomes almost meaningless when we try and carry over it into the physical world. Our real interactions are more nuanced and more complex than this. The purpose of this kind of thing is to make us question what's actually happening when we like something. What's actually happening when we poke someone. These things which we have metaphors for in one world don't translate very easily over into other worlds. But these worlds are colliding now to such an extent we need to try and think about them and understand them.
The separation between real and virtual has been blurred. There is no real separation anymore. A lot of our experiences are simulated as well. Take for example the car door. Car doors naturally make a sound when you close them, letting you know you properly closed your door. But because today's cars are so precisely engineered, the car doesn't naturally make this sound anymore. So now this sound is being simulated, confirming that you actually closed the door. And electrical cars have become so quiet that they don't make sound like cars with combustion engines do. The sound that regular cars make isn't a feature, but a byproduct of the technology. So now we are trying to simulate the sound of engines, because we are so accustomed to them. Not only because we expect cars to make a sound, but also for the safety of the people surrounding them. Things usually do not work the same in the physical domain as they do in the digital. These two domains work within different rules. In video games there are no physical consequences. You can simply respawn and start all over again. Video games give people a safe environment to blow off steam and do things they would never do in the real world. But it is becoming increasingly complex when the borders between virtual and reality fade. An example of borders blurring are the drones used by the American Army. These drones can be controlled from behind a computer screen. You don't personally have to be in the battlefield anymore. Drones have made it possible to kill someone with the push of a button, just like in a computer game. When you kill someone from behind a computer screen, it doesn't feel real. This can be very confusing, and most of all very dangerous. With computer games trying to replicate real life as close as possible, we are creating some interesting situations. Recent research has shown that compulsive gamers have hyperconnected neural networks, which means they could essentially think more efficiently, recognize important information in an environment, and respond quickly to this new information. There have been cases where the digitally gathered skills have helped people in real-life situations.
He's a guy who learned on a video game how to help in a real-life rescue. We're actually looking at the video game right there. A computer game called America's Army includes some lessons on medical skills, valuable medical skills that you can use, and that proved to be life-saving and life-altering for our next guest here.
I witnessed a truck flip over several times, and I was the first person to stop my vehicle, and I figured if I was the first person there, I'd be the person that could save these people. And I just went and I did it.
People seem to react different to virtual simulations than they do to the real world. In the physical world we loathe traffic jams. But strangely enough, some people are actually willing to wait in traffic jams in a video game. The once popular computer game Second Life made people think about actually living in a totally virtual environment.
In January of 2007, a man named Molotov Alva disappeared from his California home. Recently, a series of video dispatches by a traveler of the same name have appeared within a popular online world called Second Life. What follows is his story.
When I fell into the world, from the heavens, I had less than nothing. Forget about clothes. I didn't even have skin. I soon discovered that in this brave new world, everything, from who I was to what I looked like, was changeable. I could be whoever I wanted, for a price. Did I want to be strong, tall, big, small, black, white, muscle-bound, perhaps older, or maybe a perfectly rendered digital facsimile of my carbon-based self? I think it was Albert Einstein who said, "Reality is merely an illusion, albeit a persistent one." So if this new reality was an illusion, did its persistence depend upon me? To my eye, a city here was not a real city. A street was not a real street. Even walking wasn't really walking. This was a place where nothing was what it said it was. Even I was a fabrication. In this new world, I could stand on a beach, but could I taste the salt hanging in the breeze, feel the sand crunch beneath my feet, dip my toes in the water, and shiver from its coolness? All that I saw and experienced relied on memories I had from my other life. This place could only create an approximation of a beach. It was up to my mind to do the rest. But then I realized, the world I left was also composed of imitation objects. My leather sofa hadn't been real leather, nor was the non-dairy creamer in my coffee. Nearly everything in my old life was counterfeit, made to resemble something else. Why should this new place be any different? Since I no longer needed sleep, did I need a bed? And since I didn't eat, my kitchen, my dining table, served no purpose either. Nor did I need an office. To be honest, everything in this house was ornamental, harmless, I told myself. Or was it? I suddenly realized something. The new home I created was dangerous. It was trying to make me nostalgic for the life I once had, the life I'd come here to escape.
Games like Second Life make us look at the real world in another way. Technology reveals its own world. These worlds aren't necessarily comparable to their natural variants. They can develop their own kind of language and aesthetics. GPS, aerial photography, drones, and surveillance cameras are new ways of perceiving the world. It's not what we see, but it is what the technology is seeing.
The photographer Garry Winogrand famously said, "I photograph to see what the world looks like in photographs." Despite frequent approving citations of this aphorism, few creators and critics take it seriously. Often called one of the great street photographers, Winogrand is best known for portraying American life in the mid-century with a snapshot aesthetic. "As far as photographing goes," says Winogrand, "all I'm interested in is the pictures, frankly. I went to events, and it would have been very easy just to illustrate that idea about the relationships between the press and the event, you know. But I felt that from my end, I should deal with the thing itself." His works are not commentaries, they are precisely the opposite. Garry Winogrand makes photographs not to capture what he sees, but to see what he will have captured. That's what it means to take photographs, to see what the world looks like in photographs. Because light bent through an aperture onto emulsion.
Most people see the technical image as a window into the world. We think we can trust our own eyes. We see images as reality. The philosopher Wilhelm Flusser is worried about this lack of criticism towards the technical image. In a time where images are replacing words, this lack of criticism does indeed seem dangerous. The objectivity of images are an illusion.
但当各国元首在曼德拉追悼大会这种肃穆场合开始玩起自拍，整个世界也就跟着踢笑了。
We are 100% owned by Jimmy Lai. He's the biggest online newspaper in Hong Kong and Taiwan as well. So we're also the first one to step into the digital world. He believed that the next generations, they will not read newspaper anymore. They will just pick up their phone and then reading the news online and using their mobile apps. Reading text is kind of time consuming, and watching video is much easier for them to digest the news story. He see that the paper is dying, and he believe in the next generation medias will be animations.
The 61-year-old driver reacted by hurling an 8-pound rubber wheel block directly into the 23-year-old's face. He then proceeded to beat the living shit out of the guy.
Is it journalism?
Of course it's journalism. It requires journalism skills to do well, and the rules of journalism have not changed. We still apply the same rules. As long as we can get the information, then it can become an animation.
Are you bringing the truth?
Are we bringing the truth? Yes. I mean, every day we bring the truth in our animations.
As soon as our news is being replaced by exaggerated and misleading computer simulations, we'll lose all nuance and honesty in the communication of news to people. Our methods of digital communication aren't directly comparable to its natural variant. When we communicate digitally using text, our body language is lost. We try to circumvent this by using things like emoticons to replace our genuine body language. Translating our complex, wide-ranging human emotions into a set list of emojis is absurd. This is an example of humans trying to transform themselves to make the technology work. Our rules for digital communication differ from its natural variant. Sending a text message to notify someone of the passing of a family member or friend is considered rude and blunt. Although in time, as people are getting more synthesized to the technology, it could very well be considered normal. Technology has the ability to change our morals. Even though technology isn't even coming close to simulate the complexity of human communication, technology could play a huge role in improving our modes of communication. Jaron Lanier, as much a technology lover as a technology critic, most famous for coining the term virtual reality, writes about his fascination for cephalopods. These highly intelligent creatures are able to transform themselves into any shape of color as they wish. Lanier dreams of a future where we, with the use of virtual reality, are able to do this ourselves. If we would be able to transform ourselves into anything we wish, we wouldn't need to use metaphors anymore when we're talking. We could actually become them. It would enable us to develop a much richer language. In this kind of communication, you can imagine we transcend the spoken language and actually become it. What do we consider to be real anymore? The classical meaning of real would be something you can see and physically touch. Something that is not artificial or imitated. In the 19th century, there already were discussions about reality. Stereoscopic images were in some cases considered controversial. The technique of taking two pictures at slightly different angles resulted in the ability to capture a small part of reality in 3 dimensions. But instead of taking pictures at a slight distance, comparable to the distance of our eyes, it also created the ability to increase this distance. This resulted in images with much greater depth range, greater than we as humans could naturally witness. The Catholic Church wasn't very happy about this. This kind of view is unnatural for humans to see, and this sort of scale of the world should only be allowed to be seen by God. The computer has made it possible to reproduce and simulate almost anything. We live in the age of the non-physical object. Instead of having a bookcase full of books, you can now simply have thousands of books on your hard drive. There is no real need for a lot of physical items anymore. This has also resulted in a change of our perception of value. We understand the monetary value of physical objects, but with digitization it has become harder for us to value a digital file.
Apple has decided to remove a $1,000 app from their iPhone App Store. It's called I Am Rich, and you literally pay $999.99 for it, and it does nothing. It just displays a red gem on your home page on your iPhone, and it just kind of flashes a little bit, and that's it.
Technology is at a high state of abstraction. Computers have in some ways surpassed the understanding of their users and have become indispensable to them. With a lack of adequate technical literacy, combined with processes of blackboxing, these systems themselves resist interrogation. Instead of us programming intelligent machines by using a top-down approach, which would mean that programmers would code every single bit of knowledge into these machines, programmers now use a bottom-up approach, resulting in machines that can now develop themselves, using biological principles. With technology becoming increasingly more intelligent, using this approach, our relationship to technology is becoming even more complex.
You asked for it. I am Electro. My brain is bigger than yours.
Let me show you something.
Okay, that's a cat sitting in a bed. The boy's petting the elephant. Those are people that are going on an airplane. That's a big airplane.
This is a 3-year-old child describing what she sees in a series of photos. She might still have a lot to learn about this world, but she's already an expert at one very important task: to make sense of what she sees. So ultimately, we want to teach the machines to see just like we do, naming objects, identifying people, inferring 3D geometry of things, understanding relations, emotions, actions, and intentions. The first step towards this goal is to teach a computer to see objects, the building block of the visual world. In its simplest terms, imagine this teaching process as showing the computer some training images of a particular object, let's say cats, and design a model that learn from these training images. How hard can this be? After all, a cat is just a collection of shapes and colors. And this is what we did in the early days of object modeling. We tell the computer algorithm in a mathematical language that a cat has a round face, a chubby body, 2 pointy ears, and a long tail, and that look all fine. But what about this cat? It's all curled up. Now you have to add another shape and viewpoint to the object model. But what if cats are hidden? What about these silly cats? So about 8 years ago, a very simple and profound observation changed my thinking. No one tells a child how to see, especially in the early years. They learn this through real-world experiences and examples. So instead of focusing solely on better and better algorithms, my insight was to give the algorithms the kind of training data that a child was given through experiences, in both quantity and quality. Once we know this, we knew we needed to collect a dataset that has far more images than we have ever had before, perhaps thousands of times more. And together with Professor Kai Li at Princeton University, we launched the ImageNet project in 2007. We downloaded nearly 1 billion images and used the crowdsourcing technology like Amazon Mechanical Turk platform to help us to label these images. As an example, in the case of cats, we have more than 62,000 cats of all kinds of looks and poses, and across all species of domestic and wild cats. As it turned out, the wealth of information provided by ImageNet was a perfect match to a particular class of machine learning algorithms called convolutional neural network. Just like the brain, is consisted of billions of highly connected neurons. A basic operating unit in a neural network is a neuron-like node. It takes input from other nodes and sends output to others. Moreover, these hundreds of thousands or even millions of nodes are organized in hierarchical layers, also similar to the brain. So here's a computer algorithm telling us the picture contains a boy and a teddy bear, a dog, a person, and a small kite in the background. Or a picture of very busy things like a man, a skateboard, railings, and lampposts, and so on. Other times, our computer algorithm is remarkable at telling us what exactly the objects are, like the make, model, year of the cars. We developed a model that connects parts of visual scenes, like visual snippets, with words and phrases in sentences. About 4 months ago, we finally tied all this together and produced one of the first computer vision models that is capable of generating a human-like sentence when it sees a picture for the first time. Now, I'm ready to show you what the computer says when it sees the picture that the little girl saw at the beginning of this talk.
A man is standing next to an elephant. A large airplane sitting on top of an airport runway.
Of course, we're still working hard to improve our algorithms, and it still has a lot to learn.
Using this kind of approach, technology is becoming increasingly more intelligent, resulting in an even more complex relationship to technology. People will always in some ways ascribe human characteristics to objects. This effect is called anthropomorphism. The question, if things can actually have real emotions, has been part of many philosophical conversations. But even if there would be no possibility for objects to have real emotions, we ascribe emotions to them anyway.
A traditional Japanese funeral ceremony with a difference. The deceased here are all robot dogs. Rolled out in 1999, these were the world's first home-use robots equipped with artificial intelligence. They were even capable of developing their own personalities. In all, more than 150,000 pets found loving homes, and the final generation could even talk.
The people who have them feel their presence and personality, so we think that somehow they really have souls.
Sony discontinued the line in 2006, and the after-sales clinic finally closed down last year. But this small group of retired engineers have taken up the challenge, repairing, or they would say curing, the broken robots with spare parts.
I was surprised the first time I spoke directly to a client. He told me, "He's not very well, can you examine him?" I realized that he didn't see it as a robot, but as a member of his family, whose life was more important than his own.
物一つ一つに対して日本人は結構海の神とか物一つ一つに魂があるっていうような感覚を持ってるので、例えばそのロボットが自分のペットであるがごとく動く。で我々としてもそういうロボットを今度はいただいて、なんか部品に使うとかいう時にはやはりそのロボットから一度魂を抜く、魂をオーナー様にお返しをする。例えばお寺でお葬式をやったりですね。で私たちがロボットをお寺に持っていったのは、要するにそのオーナー様から預かったやはり魂を抜こうと、やっぱり魂が入ってますから。
The technology doesn't have to be very advanced for us to anthropomorphize it. But when simulations come very close to reality, it usually results in an uneasy feeling to the user. This is called the uncanny valley, where things simultaneously feel familiar and foreign.
Our society is filled with simulations. It becomes really confusing when we don't even know if we're dealing with a real person or artificial intelligence. These situations already exist. The ability to judge something as real is important in order to retain our own human authenticity. We react differently to real humans of flesh and blood than we do to bits and bytes. I think if we stop being able to distinguish between the real and the imitated, our communication and interactions will change immensely. We risk losing our individuality by trying to adjust ourselves to the technology. A Dutch Twitter user was questioned by the police after one of his Twitter bots made a death threat. His bot takes random words from his tweets to form them into new tweets. These situations lead to new questions. Is the programmer responsible for the outcome? The invention of language and writing have been very important for the human species. In this experiment, I wanted to see if it was possible to simulate language and writing. Using artificial neural networks, trained on thousands of books and thousands of examples of handwriting, I was able to generate a robot letter. The input I had on this process was combining these techniques, choosing the color of the pen, the sort of paper, and paper size. All the characters generated are unique and look very human-like. In one of the letters, the robot seems to be getting stuck on one striking word: consciousness.